Chemistry 30 Redox reactions. This is lesson 3, balancing half reactions through the half cell method. Steps for merging half reactions. First, in order to eliminate electrons, the half reactions may have to be multiplied by coefficients, so there are an equivalent number of electrons on either side of the reaction arrow. Once the equations are merged, duplicate species on opposite sides of the arrow are eliminated. Example 1, write the balanced equation when Ag plus reacts with MnO2 in basic solution to form MnO4- and Ag. Then identify each half reaction as reduction or oxidization. We have been asked to convert this to basic solution. Now note, it is easier to convert to basic after the merge. It's less work than converting both of the half reactions to basic before the merge. Why do it twice when you get the same result just doing it once at the very end? So I will not convert to basic solution until I have merged my half reactions. My first half reaction is easy. I just have Ag plus going to Ag. The silver already balances, oxygens balance, hydrogens balance. It's just charge I need to balance. I add electrons to the side that is more positive, so I add one electron to the left-hand side, and now my charges are balanced. The electron is on the left, which means it's going into the reaction, so I am gaining electrons, and gaining electrons is reduction. So this line is reduction. The other half reaction has MnO2 turning into MnO4-. Manganese is already balanced. Now I have to balance oxygen. I have 2 on the left, 4 on the right, so I need 2 more on the left. So I add 2 waters to the left-hand side, and now I have 4 oxygens on either side. Now to balance out hydrogen, I have 4 on the left, none on the right. So I need 4 more hydrogens on the right. So I add 4 H pluses to the right-hand side. Now to balance charge. I have a charge of 0 on the left. On the right, I have a -1 and a +4. So that is a +3 overall. So to balance charge, I will need more negatives on the right-hand side. And if I add 3 electrons, the left side now equals the right side in charge. And since the electrons are on the right-hand side, that means the electrons are leaving. And when I lose electrons, that is oxidation. Now I'm going to multiply the top line by 3 because I want the electrons to cancel out. And if I multiply the top line by 3, that will give me 3 electrons, 3 silver ions, and 3 silver atoms. And when I merge them, the electrons will now be able to cross out. 3 on the left, take out the 3 on the right. Nothing else factors out. So when I merge these two lines, I wind up with this: 2 waters, 1 MnO2, 3 silver ions, and on the right-hand side, 3 silver atoms, an MnO4- and 4 H pluses. Now to convert to basic solution. Basic means, well, I can't have H plus because H plus is acidic. So to get rid of the acids, I have to add OH-. The equation is balanced, so whatever I do to one side, I'll have to do to the other. So since I have 4 H pluses, I will add 4 hydroxides to either side. An H plus and an OH- make water. So 4 H pluses and 4 OH- will turn into 4 water molecules. Now I get rid of the duplicate waters on either side. I have 2 on the left, 4 on the right, so I can get rid of 2 water molecules on either side of the reaction. So those 2 water molecules on the left are gone, and the 4 on the right then become 2. So in the end, I wind up with 4 hydroxide plus an MnO2 plus 3 silver ions, turning into 3 silver atoms, 1 MnO4- and 2 water molecules. When dichromate is used to oxidize sulfur, the products are sulfurous acid and chromium-3 ion. Write the balanced equation and identify the half reactions as reduction or oxidization. So first we have dichromate becoming chromium-3 ion. I balance out everything with the exception of oxygen and hydrogen to start. I have 2 CRs on the left, so I need 2 CRs on the right. Balance out oxygen by adding H2O to the side that needs more oxygen. Right now I have 7 O's on the left and none on the right, so I will have to add 7 H2O's to the right-hand side. Now balance out hydrogen by adding H plus to the side that needs more hydrogen. I have 14 H's on the right and none on the left, so to balance hydrogen I will add 14 H pluses to the left-hand side. Now to balance charge. On the left I have positive 14 and minus 2, which adds up to a total of plus 12 on the left. On the right-hand side, I have a plus 6 and water has no charge, so the overall charge on the right is plus 6. To balance charge, I add electrons to the side that is more positive, so I will add 6 electrons to the left-hand side. Now both sides equal plus 6. The electrons are on the left-hand side, which means they are going into the reaction, which means it is gaining electrons reduced. This is a reduction half reaction. Now for the other half reaction. Sulfur is becoming sulfurous acid. The S's are already balanced, so I now balance oxygen by adding 3 H2O's to the left. Now I balance hydrogen. I have 6 on the left. There are already 2 on the right, so I need 4 more H's on the right-hand side so that I have 6 H's on either side of the equation. To balance charge, I don't have anything with the charge on the left. On the right-hand side, I have a plus 4 charge. So to balance charge, I will add 4 electrons to the right-hand side. Now both sides are equal to 0. The electrons here are leaving the reaction. Leaving is losing electrons oxidized. So this is an oxidation half reaction. Now I will want to merge these two reactions, and to do that successfully, I will have to make sure that the electrons cancel out. I've got 6 electrons and 4 electrons. The smallest number they can both go into is 12. So I will multiply the top line by 2 and the bottom line by 3. That'll give me 12 electrons, 24 H pluses, and 2 dichromates, which become 4 chromium-3 ions and 14 waters. In the second line, which I multiply by 3, that will give me 9 waters, 3 sulfurs, 3 sulfurous acids, 12 H pluses, and 12 electrons. Now the electrons will completely cancel out. I have 28 H pluses on the left and 12 on the right, so I will take 12 away from both sides. So 28 H pluses subtract 12 H pluses leaves me with 16 H pluses, and that will get rid of the H pluses on the right-hand side completely. I have 9 water molecules on the left and 14 on the right, so I will take 9 water molecules away from both sides. So 9 water molecules subtract 9 water molecules means there will be no water on the left-hand side, and 14 water molecules subtract 9 water molecules will leave, and 5 water molecules on the right. Now I will merge the two lines. I've got 16 H pluses, 2 dichromates, 3 sulfurs, 4 chromium-3 ions, 3 sulfurous acids, and 5 water molecules. And the equation is now balanced. Example 3, write a balanced equation for a reaction between chromate and ammonia in basic solution that produces nitrogen monoxide and chromium-3 ion. Also, identify the half reactions as reduction or oxidation. So first we have chromate turning into chromium 3 ion. The Cr already balances, so now I balance oxygen. I have 4 on the left, I have none on the right, so I will add 4 waters on the right-hand side to balance oxygen. Now to balance hydrogen, I have 8 on the right and none on the left. So I will need 8 H's on the left, so I will add 8 H pluses to the left-hand side. To balance charge, I have a plus 8 and a minus 2 on the left, which is a total of plus 6. And on the right-hand side, I have a plus 3. I add electrons to the more positive side. I will add then 3 electrons so that both sides equal positive 3. The 3 electrons are going into the reaction, so that means it's gaining electrons, and gain electrons is reduction. In the other half reaction, I have ammonia turning into nitrogen monoxide. The ends already balance, so now I balance O. I balance O by adding water to the side that needs more oxygen, which is the left. It needs 1 more oxygen, so I add 1 water. Now to balance hydrogen. I have a total of 5 H's on the left and none on the right, so I will add 5 H pluses to the right-hand side. To balance charge, I have no electrons on the left, no charge on the left, and I have a plus 5 charge on the right. So I will add 5 electrons to the right-hand side so that both sides have an overall charge of 0. The electrons are leaving, that means it's losing electrons, and when you lose electrons, that's oxidation. So let's merge these lines. And we're going to do that by making sure the electrons cancel out fully. The smallest number that 3 and 5 can both go into is 15. So I will multiply the top line by 5. So I have 15 electrons in that line. And I'll multiply the bottom line by 3. So I will have 15 electrons in that line. So the electrons can fully cancel out. So when I multiply the top line by 5, that'll give me 15 electrons, 40 H pluses, 5 chromate ions, and that will turn into 5 chromium 3 ions and 20 water molecules. When I multiply the bottom line by 3, that gives me 3 waters, 3 ammonias, 3 nitrogen monoxides, 15 H pluses, and 15 electrons. So the electrons on either side will cancel out. I have 40 H pluses and 15 H pluses, so I will take 15 H pluses away from either side. So that will leave me with 25 on the left and none on the right. I have 3 water molecules on the left and 20 on the right, so I will take 3 water molecules away from either side, which will leave me with no water on the left and 17 water molecules on the right. I will then add this all up, and that gives me 25H plus, 5 chromate ions, 3 ammonia molecules, 5 chromium 3 ions, 3 nitrogen monoxide molecules, and 17 water molecules. Now I have to switch this over to basic solution. Right now I have 25 H pluses. So to switch to basic, I will add 25 OH minus molecules to either side. When 25 H pluses encounter 25 OH minuses, they make 25 water molecules. Now I get rid of duplicate water molecules on either side of the equation. So since I have 25 on the left and 17 on the right, I will get rid of 17 waters on either side of the equation. So 25 water molecules subtract 17 water molecules will leave me with 8 water molecules, and there will be no water left on the right-hand side. So in basic solution, I have 8H2O plus 5Cr042 minus plus 3 NH3s become 5 Cr3 pluses, 3 NOs, and 25 OH minuses. And that's the end of the lesson. You're good to work on the RO10 and 11 assignment.